Welcome everybody again, also from my side. My name is Umut Canzales. You can just call me Umut. Also, I'm from University of Innsbruck, also the leader of the work package regarding the demonstrators in OntoCommons project. And this session we prepared together with my dear colleagues from the work package 5. I guess for you it doesn't mean anything, but from the demonstrator work package. Anna, Dragan, who's not here right now, but I hope he's online. Christian and Jan, they're both here. And we wanted to do something interesting and a little bit more fun, also wake everyone up. So if you ever joined an academic conference in the last 10 years, you might have seen already that they have these poster sessions, and before these poster sessions, they have this 1 hour slot where each poster presenter basically presents their posters in 1 minute. And this is we try to imitate here, and this is groundbreaking right now because I never seen this done hybrid. So it will be an interesting experiment also to see how this can work in a hybrid setting. But yeah, we have 1.5 hours for 28 posters, so 1 minute per poster. It should fit with all the transitions and technical issues in between. I'm anticipating, so we should be fine. But before we go into that, let me give a brief introduction to OntoCommons Demonstrators. The project showcases 22 demonstrators from domains like nanotechnology, nanomaterials, advanced materials, manufacturing, and biotechnology. Each demonstrator adapts semantic technologies in their use cases to some extent to address their challenges. We started with 11 of them initially as part of the project, and then we acquired another 11 with the help of our, of course, project partners and their vast network. At the end, we have now 22 demonstrators. Demonstrators are very important. They are the cornerstone of our work, right? Because the exchange between OntoCommons and demonstrators facilitate, first of all, understanding the challenges of data documentation and semantic technology adoption in industrial scenarios. And as you may already know, and we will see in the afternoon, we are preparing a roadmap for basically as an agenda for the next N years for research, development, education, and more. And the input we collect from our demonstrators, the people who really actually do the stuff and not like us academicians sit in ivory towers, what they think, what kind of valuable input they provide. This also helps us shape the roadmap for this upcoming N years. And at the end, as a return, we also try to help them basically adopt different parts of OntoCommons outcomes that can help with their current and future use cases, which, of course, at the end of the project will help us to verify the results we have if they created any impact or not. These are an overview. This is an overview of the demonstrators currently we have. As you can see, I mean, it won't be very sensible to talk about them individually today, right now, but you will see many of them have posters outside, and we have, after this session, after the break, another session where we have 3 demonstrators who give more detailed insights from Technica, IKEA, and Bosch. Right. Okay, I already talked about this stuff, so I will see. I hope now everyone can see.
Yeah.
Okay, great. Yes, so we have 22 demonstrators, and many of them have posters here already, and the ones who are not here, you can still read about them on our website, where you can find here basically all about them. You can read. Good. So the poster presentations. So poster presentations are not only about demonstrators, because we also have to the external participants that are interested in our project or we cooperated somehow in the back, and they also wanted to share their results. So we have posters from both demonstrators and external participants. You can see the posters at the foyer in the evening. We will have a networking session from 6 to 8, yeah, if I'm correct. And who are not lucky enough to be here, for the ones who are not lucky enough to be here or had other pressing issues, there will be an AirMeet booth between, again, 6 and 8 in the same system we're using for the presentation today. You can also visit the posters there. And they will be uploaded to the OntoCommons website after today, some point. I don't know exactly when, but it will be after today.
We received some of them yesterday. So
Exactly. So it will be after today, but they will be available also online. All right. So the ground rules for the poster presentations, we will come now. We have 29-ish poster presentations. Well, 28 plus 1. The last one is still on the edge. I don't know if Gerhard is here or will be here, but probably not. But let's say 29. Yeah. The presenters already received this order, so you know more or less after which. It's important that you know which title is yours, but also important which is before you. Yeah? So when you sit and you're prepared to come here, so pay attention, please. Which one is before you? This also goes for the online participants, of course. This is the first half, and this is the second half. But you already have this list on your computers, I hope, already. And there will be a 29th, maybe. We'll see. Okay. The rules are very easy. So I have a stopwatch. I'm not joking. I really have a stopwatch. And every poster has a title slide here, right? And when you see your title slide, well, before you're speaking, maybe you can always stand here, right? So when you see your title slide, then come here, and then you will have a microphone. So this one is your microphone. Well, this is more relevant to the, obviously, physical speakers. This one is a microphone. I will basically turn this on, and I hope there won't be any crazy feedback or something. Yeah, and then you can speak. And after 1 minute is out, then I will start bothering you and skip the slide. Yeah? So this is basically the rules. Everybody has the same rules. 1 minute means 1 minute, no hard feelings. Yeah, that's basically the rule. And the same goes for the online participants. We can be a little bit lenient with the online participants if they have technical issues. Yeah? So it's okay. And for the online participants, of course, you are all now assigned a speaker, so you should be able to immediately just start talking when you see the title slide of your presentation, of your poster. All right. If you have not submitted so far any teaser slides, you are still here. So your title will appear here. And if you still want to talk about your poster for 1 minute without teaser slides, like improvise it, freestyle, it's still possible. You can still do it, no problem. All right, good. Then I think if everyone is ready, is Adije here? Or are they online? Okay. So, Francesco, please.
Okay. Hi, everybody. Okay. Hi, everybody. I'm Francesco Compagno, PhD student, and today I'm going to present Adige's poster. Adige is a company, part of the enterprise group named BLM Group, which manufactures laser cutting machines. These machines are hugely complex. Their maintenance in particular requires advanced expertise. The goal of the company at large is to reorganize this maintenance expertise, and in order to do so, he is investigating semantic technologies, in particular in the OntoCommons projects, and is collaborating with the Laboratory for Applied Ontology. The resulting efforts produced ontologies contain domain terms, as well as methodological guidelines for functional and structural modeling of engineering system and failure analysis. And if you wish to know more, you can join the poster session this evening.
Amazing. Thank you very much. Perfect example for the first presentation.
Then you have the second one. So the other part of the experiment, physical one. So hello. So I will present this.
Wait.
Sorry.
It's on.
It's okay.
Yeah.
Yes.
Yeah.
Good. Thank you. So this is a case that we developed in another European project that finished now, quality. It is with Airbus, and the objective is to allow engineers of the aircraft design to talk through systems to industrial engineers so that they realize correctly the designs that they did. So we developed an ontology based on IOF ontologies BFO and IOF core, and linked to system engineering with an ontology for model-based system engineering, Go PPRE. So, and then in this slide, there is also a video when you can see, so don't turn on the sound if you do it in your own, because it is cut. So, and you can see so the flow of information. So the ontologies, they have been used to create knowledge graphs, which includes all the data for 18 scenarios to be realized. And the objective is for the industrial engineers to select the best one according to some criteria to do it. And they did it by doing a 2D simulation and a 3D simulation for the ergonomics, because airplanes are huge things. And the people, so the workers, they have to be inside in order to do the manual assemblies.
All right.
Done?
Done.
Thank you.
All right. So the Basajan project is an EU project that covers the full value chain from the forest to the wooden building, promoting the sustainability in this chain and bringing forward these indicators. You can change to that slide.
You can change yourself.
Sorry. Yeah. This is a huge challenge for us with the interoperability, since we're covering so many domains. So we started to model this in an information model that just grew, and we just, So we figured out that instead of that, we're doing a bottom-up approach. We created a tool that is a kind of a workshop tool to sit together and try to stream instances into a tool to analyze what kind of data do we have and how can we connect it. So we bring this concept further now, creating a specific application called Wood Launch. And it's actually some kind of interactive real-time app that you can stream instances into and co-create information models together and discuss inside of the application to try to understand your data, and then probably export this data out in some other ontology tool or in some other system so that you can play around with the instances. So during this week, I hope to discuss with you and see how we can bring in more depth from the ontologies into this kind of tool, and we can play around with the tool and see what kind of features we would like to have. And of course, this concept could be used in other domains than wood domain as well. So we can thematize this to work in whatever kind of situation where we need to discuss interoperability between actors.
All right. So, do we have anyone from Biomat DB here? No? Online? If the participant from Biomat DB is here, please start talking.
Works for some reason.
Oh, yeah, now we hear you.
I don't know why, but now it works.
Okay, great.
Okay, so I'm ready.
Okay, then I tell you to start in a minute.
Perfect, thank you.
Please go.
Can you show the... Perfect, thank you. So yes, I'm from the BiomatDB project, and the BiomatDB project is also a coordination and support action with a duration of 30 months. The project will end in November of 2024. And we aim to develop a biomaterial database that provides information on the chemical, physical, biological, and toxicological properties of biomaterials, and also a biomaterial marketplace that presents supplier organizations and their biomaterial products to demanders like hospitals, industry, medical institutes. The poster that will be presented today, if you go to the next slide, focuses on the... Is the next slide missing?
Yes. There was no
Oh,
next
no.
slide. The one.
There was a graph on the next slide, but it doesn't matter. Let's just improvise. The biomaterial database is the focus of the poster today, because here we will also make use of automatic content retrieval and data harvesting techniques, and most importantly, advanced natural language processing components and ontologies. And this is why also data harmonization, keeping the FAIR principle, is really important. And to also enable this essential step of automatic processing, we also map biomaterial concepts to existing ontologies, and we also use named entity recognition processes, along with linking the terms to the ontologies to create this really structured resource of a database.
Time is up.
Thank you.
Good. Bosch? Is Bosch here? I think this was them. Okay. Anyone online from Bosch? Evgeny is online. Can you make Evgeny a speaker, please? So this is why we have 1.5 hours for this 30 posters, as you can see.
I think there's an icon and
Yeah, they are assigning him now as a speaker, I think. Evgeny, you are able to speak, I think, now. Yeah. Evgeny? Hello? I see you're a speaker.
Hello, can you hear me? Hey, do you hear me?
Yes, Evgeny is doing double hybrid now, so he's in Oslo, but also online.
Yes. Yeah.
Okay, great.
Okay, so you can see me, right? Okay, let me do the screen sharing.
You see the slide, just tell me to change it when you need it, yeah?
Oh, I cannot share it from my side.
No, but just, I have your slide already. Okay, you don't have a slide. Well, you didn't send me a slide, but if you you can talk about it.
Okay, I thought I was going to share. Okay, can I share the screen? I can just share it. I have it on my laptop.
Yes, okay, you can share then. Let's do it, and I hope it doesn't break anything.
Only one person can share it. Okay, let me just.
Right now, please. Yeah.
Okay. Select window. Select window screen. Entire screen. Okay, now it should work. Do you see it sharing?
Yes. All right.
Okay.
You have 1 minute. Go.
Okay, right. In the poster, you will learn today about Bosch challenges and Bosch solutions for smart manufacturing with the help of ontologies, executable knowledge graphs, and our Python library. And our main problem is automated welding, how to connect pieces of metal together. We developed it for spot welding, but it's also applicable for other ways of connecting metal. And yeah, this is how it works. You put two pieces of metal together. Applications are production of car bodies, so this type of manufacturing, which is very data intensive. Zillions of data points generated, billions of data records generated in one production day. So what we develop in Bosch is the solution to analyze this data and predict quality of the welding operations. And so we do this with ontologies, we address communication problem, data integration problem, and machine learning generalization problem. In the poster, you will learn some of the aspects of what we do. You will learn about the welding ontologies. You learn about executable knowledge graphs, and you learn about the Python library for analytics of non-machine learning experts. Essentially, the whole solution is targeted to people who don't know much about machine learning, but who would like to do their own homemade machine learning solutions for automated manufacturing. And for these people, we have this whole suitcase of solutions, and about three of them you will learn today. Special type of ontologies, executable knowledge graphs, and our smart Python library. Just come to the poster and enjoy the show. Thank you.
Thank you very much, Evgeny. So I tried to share my screen again. Oh, even this works, I think. All right. Do we have anyone from Cameo?
Yes, it's me, Pierluigi here. Can you hear me?
Yes.
Hello, everyone. I'm Pierluigi Del Nostro. I here briefly introduce the work done with Gerard Goldbeck on the materials characterization ontology. Next, please. Next, please. Okay, this work lies in the field of material characterization, which encompasses a wide range of methods and related research communities. And this has led to a proliferation of terminologies and approaches, hindering collaboration and interoperability. To develop a shared knowledge and improve interoperability in the characterization domain, we started developing ontologies within the OntoCommons European project, which aims to develop harmonized and widely accepted characterization methods. Next, please. Specifically, the demonstrator is about the characterization methodology ontology, the CAMEO, which is a domain ontology designed to capture methodological aspects of characterization methods that are in common across different techniques. In the modular design approach that we have adopted, the goal of this ontology is to provide a reference framework for the development of technique-specific ontology. CAMEO is based on the EMO as top and middle level ontology. Thanks for your attention.
All right, thank you very much.
Thank you.
We have extraction of empirical ontology design patterns. I know she's not here, but is Valentina online? Do you see Valentina online? Okay, looks like it's not. But interesting work. It's about extracting ontology design patterns from existing knowledge graphs, as far as I remember. So if you, and I can imagine this is very useful for many industrial use cases. And if you're interested to know more about this poster, please visit the online version of this basically session in the evening, where you can see also this poster in AirMeet, and also later when it's published on our website. Yeah, and you can I think you can already find the contact information of Valentina there. So feel free to also contact her if you want to learn more about it. All right. I'm under 1 minute, so I continue. Yes. All right. And the next one, confirm smart manufacturing. I think Yahya, was it yours? You should be able to enable yourself. The microphone, I mean. Yeah. If you just try to unmute. Oh, mic is disabled as the host has hidden you from the stage. Why did you hide Yahya?
Thank you.
Okay, now we have you. Great.
Good morning, everyone. Can you go to the slide? Yeah. Hi, I am Mohammad Yahya, and I'm PhD final year student. I'm working under Dr. John Breslin and Adi Intizar. I'm going to present my PhD work that is building semantic models and knowledge graphs for intelligent smart manufacturing. Can you go to the next slide, please? Thank you. In any manufacturing production line, manufacturing process and assembly process are performed to produce a product. During the manufacturing process, a huge amount of data is generated that is scattered in different formats and different storages. Due to the lack of availability of unified model, almost part of the data is wasted. In a manufacturing production line, in current manufacturing production line, expertise lies at the staff level. That means like if a supervisor or engineer is not around, so it's a bit hard to tell what machine is performing what task. Can you move to the next slide, please? Thank you. Currently, in my PhD work, I just identified like there is the existing ontologies are unable to cover the overall production line. So the current ontologies faces a lot of efforts to modify to bring it to the needs of current like any manufacturing production line. Most of these ontologies they are present.
Oh, that was very loud. But okay, let's finish it up.
Okay, are very specific to some applications, and they are unable to cover the production line. There are some issues with the real data set are not available for the validation purposes, and the knowledge graphs built on the top of these ontologies are sometimes are having missing links. So you see on the right side of the figure, which is figure 2. So we are proposing ARGOM, which is one of the ontology I proposed during the PhD work. This ARGOM can be used as a domain level or manufacturing level ontology that can be used as for the aligning purposes for the application specific. It can be adopted with the minimal modification to build knowledge graph, and we proposed a manufacturing data set.
Thank you for the presentation. You're already like 3 times over the time. So, but will you be around in the evening at the poster session? Hello? Yeah.
Hi. Yeah.
Yeah. So you will be around in the evening, right? After 6?
Yeah.
Okay. Maybe then in more detail you can discuss with the people there.
Yeah. Thanks.
Right. You're welcome.
So hello everybody, I'm Silvia Chiacchiera. So this poster is about a demonstrator, OntoCommons Demonstrator, and also collaboration with the DOM Marketplace project. So the idea is about interoperability between marketplaces to support federated queries and ingests. And the benefit is to provide OntoCommons with prototypical needs from digital marketplaces and similar platforms in this line of research. So the background are the WIMP ontologies. So WIMP was a marketplace project and a middle-level ontology called EVMPO. And the update is a collaboration with the DOM marketplace project to improve the alignment of their ontologies with the OntoCommons ecosystem and EMMO. And yeah, you can see on the right figure where you see concepts from DOM aligned to the MMO. And the name of the poster you see at the bottom, so just come and talk to me if you're interested. Thank you.
Right, great. Thanks for keeping the time. I mean, we have plenty of time, but also it's about to be fair, to everyone. Okay. So, EMO's theoretical foundations. Yes, Francesco.
I'm Francesco Zaccarini. Yeah. Okay, sorry. EMO is a new foundational ontology developed with the support of the European Material Modeling Council, part of the OntoCommons TRO. It has 3 peculiarities. It rests on applied sciences. It has a pragmatic distinction between theory and meta-theory, as applied ontology is not metaphysics, and we want to be pragmatical about that. And it has a non-standard architecture. Basically, we don't have a taxonomy, but a series of perspectives, each of giving a way to partition the logical space. Recently, we completed the formalization of the uppermost module of the theory. It is of the theory. We created a new theory for that, a mero causality. If you want to know how this relates to Feynman diagrams and robust formalization of special relativity, you can just ask, and I'll be happy to talk to you about it. Many thanks.
All right, thank you very much. All right, do we have someone from the Ethics of Ontology? Very cool title. Hello. Robert is here. All right, you can start speaking anytime.
Thank you. So this project is about developing and understanding the ethics and moral aspects of ontology development and use. It's presented as a potential new research track in ontology and in other disciplines. It's concerned with all semantic-focused artifacts, and it explores various research questions and topics, including topics common to the ethics of artificial intelligence, digital ethics, and related research fields. In the poster, I present an overview of this personal project, and it is open to formal projects and collaborations. Thank you.
All right, thanks, Robert. And the poster is outside, so if you want to take a look later. All right, Janne.
Thank you. So good morning, I'm Janne Haag from Fraunhofer IFAM, and our use case is about the feedstock quality assurance development, and at our department, we mainly deals with many industrial processes, for example, the injection molding process, and there is it consists of many different steps, like the mixing process, as well as the injection molding and the sintering and debinding step. And we focus in our use case on the we focus.
You can also read from here.
Okay. And we focus within this project with on the mixing process step, where we have many different parameters that influence this process step, and many different steps that are influenced by this parameter, like the loading beginning and then the mixing phase, and we would like to end at the stabilization phase. Okay, and within this OntoCommons project, we described all these parameters within a developed mixing ontology, which is based on a mid-level ontology BMW EMO, and is integrated in the BFO. And the goal for us is to have a time-optimized process that where it's possible to detect the quality problems in an early stage of the process.
All right, perfect. It's okay. Take your time.
I have
Yeah.
1 minute. Hello, everyone. I'm Maria
You
Kostopoulou.
can
Okay, thank you. Hello, everyone. I'm Maria Kostopoulou. I'm on behalf of Halcor, which is the copper and alloys division of Halcor, and is the largest manufacturer of copper tubes in Europe. As you can see in the map, Halcor is located in central Greece, and 2 of the production plants are being employed in the pilot case. The foundry, where the casting process takes place, and produces copper billets, which are used as raw material, and the copper tubes plant, where the finished products are being produced, the copper tubes. So the pilot case focuses on the development of data ontologies that will serve as a foundation for a data-driven decision support system for raw material procurement of copper tube production. As you can see in the pyramid chart, one domain-level ontology was developed for the procurement of billets, which was built upon BFO, the top-level ontology, and the middle-level ontology IFCore, and additionally 2 separate application-level ontologies, one for each plant. So again, the pilot case aims to demonstrate the power of semantic ontology in representing complex processes as the procurement, and also capture expert knowledge. So in very briefly, the procurement process starts in the copper tubes plant, where we receive the customer orders and also conduct the annual budgeting. We translate these inputs into orders for billets, which we place to our foundry, and then we receive back these billets, which we use as raw material for to produce the finished products. Thank you for your time and attention.
Thank you. All right. Harnessing lightweight design potentials via the materials data space. Okay, we skip you for the moment, and I will come back to you after the presentation, next presentation. Iris, yeah? Iris, I think.
Okay, shall we move on from this? Yep.
Here from here.
Okay, hello everyone. My name is Vanessa Lislevant. I'm working as a data scientist at IRES. Me and my colleague Dimitris, we're going to present you our user case. The main scope can be described as a series of field measurements to characterize airborne particle number concentration from additive manufacturing activities. We have 2 goals. First, to develop an ontology describing our case, and secondly, to integrate collected data via domain ontologies and top-level ontologies into a triple-store database. So at our poster, you will see our developed standalone ontology that covers our use case. Our attempt to integrate our ontology into the mechanical testing ontology, and also our plans to align our ontology not only with the mechanical testing ontology, but also with InnoMapper and the AM ontology. Thank you.
Perfect.
Yes.
Great, thank you.
Thank you.
All right. Do we have someone from the LCA ontology?
Yes, I'm here.
Ah, great.
Can you hear me? Okay.
Very well.
So, I'm Ilaria Maria Paponetti from the University of Bologna. Now I'm presenting a new approach for developing ontologies, ontologizing ISO standards, starting from two main concepts, simply life cycle and life cycle assessment. I organized all of 46 terms about environmental management domain listed in ISO 1440 standards. Next, please. This without missing and losing information and documentation and aligning it to MO multi-perspectives. In fact, all of LCA entities can be subclasses of different perspectives, such as semiotics, holistic, persistent, and data perspectives. Next, please. In fact, any perspectives can add information and details on the general concept that can be taken in the ISO. So a life cycle in ISO can be in MO workflow and also a semiotic object as all of the entities. Thank you.
Thank you very much. Also great time. All right. On you.
Hello, can you hear me?
Yes, I think. Yeah.
Okay. Hello, everyone. My name is Huan Yuli. I'm a postdoc from Linköping University in Sweden. I'm glad to present our...
A little bit louder.
Okay. I'm glad to present our demonstrator materials database integration using the materials design ontology. Next, please. Next, please. Given underlying data modeled in different ways and shared or queried in different ways, we face the problem that how to provide semantics aware data access and data integration over heterogeneous data, and in which these data may follow different models being shared or queried in different ways. Next, please. So our approach aims to answer this question. To solve this problem, we first outline a general framework for data access and data integration based on GraphQL. Next, please. Then we investigate how to avoid manually constructing GraphQL servers and how ontologies can be leveraged to generate GraphQL servers. As a result, we automate the generation based on ontologies and implement a prototype OBGGen. As ontologies is important to drive such a generation, we first focus on ontology construction in the materials design domain, since it's our target domain. So we develop the materials design ontology MDO. Next, please. We also apply our data access and data integration in the Optimate Consortium, which is open databases integration for the materials design domain. Next, please. Next. In addition, we developed a method to extend ontologies based on text mining and topic modeling. And we applied our approach to extend to three ontologies, which are nanoparticle ontology, e-nanomapper ontology, and our materials design ontology.
You're a little bit over time, so please wrap up.
Okay. Yeah, in conclusion, our approach can alleviate the heterogeneity among underlying data sources and provide semantics over data access and data integration. Thanks.
All right. Thank you. All right. Do we have anyone from Math Portal or Math Portal? No? Okay, looks like we don't. But we have Martin back. So I will go back to his presentation. Hello, just 1 minute, please.
But can you hear me?
Yes.
Yes, perfect. Thank you. Sorry for the interruption.
Yeah, no problem. Now we hear you better, way better actually. All right, good.
Okay, thank you. Hi, I'm Martin Huschka with Fraunhofer EMI, and what we present with our poster is how to harness lightweight design potentials via the materials data space. We show how sharing semantic data over institution creates a concrete benefit in the present use case. And our use case basically focuses on an industrial design engineer who wants to optimize an original geometry of a cast component with regards of lightweight design for additive manufacturing. So the aim is to reduce the weight of 20%, have a consistent performance, have better process parameters, that means support structures, and maximize the surface quality of the original component. This design engineer uses an algorithm that is directly connected to the materials data space in order to use and integrate process data from different additive manufacturing operators and integrate this process data with the materials data from a different materials lab that tested the components produced by the operators. So if you're interested what the concrete benefit is, please have a look at our poster. And if you have any questions or comments, please contact me with the email that is on the poster. Thank you.
Great, thank you very much. All right. This is also done. So we don't have anyone from Math Portal, if I heard correctly. Do we have from someone from ontological representations of relations between digital? I think so. I mean, you should know.
No, I don't actually. Hi, this is Akbar Sarkar, and I'm presenting it on behalf of Dusan Sarmas, Bunsam Kulpatanu, Milos, and then Saruda. This is a work done in collaboration with Ohio University and National Institute of Science and Technology from USA. So this is a comparative study of the approaches for developing an ontology for the digital artifact. What they are trying to solve is that how this digital information can be represented in the ontology in correspondence to the actual entity or the physical object. And this is very critical in terms of representing information of the product design and production plan, for example, where you need to maintain this kind of information and the correspondence. Actually, the problem is also how you can represent this information when the actual entities, for example, the physical product or the plan of the processes, the processes of the plan are not existing yet. And so, and this comparative study talks about 4 approaches: modal relation ontology, information content entity, representation specification, and counterpart relation. And this poster also shows an example based on the JET engine. And in the future, and this information will be collected and enhance the first version of the industrial ontology foundry ontology, which has been released recently. Thank you. That's all.
All right, great. Thank you. Sebastian, yes.
Hi. Can I skip here?
Yeah.
Okay, my name is Sebastian Scholze. I'm from ATB and I'm presenting the OAS demonstrator on behalf of Carl.
Come a little bit closer to the microphone.
Yeah, sure. So OAS is a company specialized in weighing systems, plant construction process, control technologies, and yard management. And this demonstrator deals with yard management. So every yard, what they are doing for their customer is highly customized. And this is done based on experience. And what we want to do in this demonstrator is to improve the decision-making. And the approach is to do this by semantically describing the data, using ontologies to support the yard setup, and using rules for this yard setup. Below you can see some examples of devices that need to be integrated. And as I said, we want to support the design and the setup of the yard. And this is done by software. And we use this software based with or together with ontologies and rules to improve the scheduling. And then I can skip. Okay. This is what we used in the ontology, but because of time, last sentence. I'm around all day, so happy to discuss the poster and the demonstrator.
Great, thank you very much. Yes, I mean, I'm a little bit more tolerant with the time for the online participants because they don't have a chance to meet you here. But the people who are physically present here, you can also meet, of course, at the poster session later. This is just for the purpose of teasers. Yeah. All right. And I also realize you use LOT methodology, so great. Maria would be happy. Is this? Do we have anyone for this poster? I think this was Abel.
Okay. I'm not familiar with it. That's a new name on the poster, so.
It was on the poster, so.
Yeah. Okay. Well, I'm Anders Järver. I'm representing the company Able. Next, please. We design and construct large plants. Examples of this are seen here, and they all are designed and constructed in accordance with industry standards. Next, please. So we have for many years been utilizing semantic technology, and we have our internal system called the MMD that is OL2 ISO 15926 Part 14 based, and the case we have for OntoCommons, and that will be presented today. I will be in Oslo later today. Is considered an extension of what we currently have. Next, please. So, industry standard content, type European standards, American standards. The content is converted into ontologies based on.
The time is almost up.
Yeah,
I mean,
and it's used for specification, product data sheets, and material certificate information. And that's it.
Okay. All right. See you in the evening. Thank you.
Yeah.
See you. Yes. Patricia, are you there?
I was talking just to myself.
All right. Great. We will hear also from you later, right? So, okay, good.
In my case, it's a very short presentation because I am giving the long presentation after the coffee break. In the poster, you will also have the poster this afternoon, but you will get a lot of details if you join the session after the break. The idea is to present what we have been doing to promote this, take advantage of this typological experiment by using semantic technologies. In the presentation and the poster, we present all the approach that we have been performed and what we have get from this. And we present both the approach and also the ontology, the modular ontology we have been developing in the framework of this demonstrator. But the details will come later.
All right.
Is that enough or too short?
You have still 20 seconds or something, so if you want to say something, I don't know.
I think that's it, and they will join the session later on.
All right. Okay. Thank you very much.
Bye.
Yes. Siemens, I think. Yeah.
Okay.
So, hello, I have no teaser slides, so I have to improvise a little bit. So,
You can come a little bit closer to the
okay, good. So the use case we are going to present is similar to the one presented by Abel, standardization and product data exchange within a bigger ecosystem. And here, this is a collaboration between the University of Oslo, team by Arild Vala, who invented the asset information modeling framework. That is meant exactly to standardize product data exchange between the parties, vendors, and customers, based on the IC standard 81346. And we are considering use case by Siemens Energy here from the compression business, where we look into the exchange of the data related to gearbox, which is a part of the gas compressor system. Okay.
Amazing.
So,
thank you.
thanks.
Yes. So you can find also Maya in the afternoon at the poster area. All right. Next one. Soulesson. Is it correct pronunciation? I have no idea, but
Yeah. I am Claude Fauconnet. I was working for many years in Total Energy, and now I work for Total Energy as an independent consultant, and I developed Soulesson's vocable, which is...
Change from here.
What?
From here.
Which one?
Any, yeah, that one's good. All right.
Yes. And starting from the fact, as non-specialist on ontology, that in industry, people should use ontologies more than they do. And to do this, we need to, as they are graphs, they need to be visualized. And that's what we work on. They are complex objects, so we need to be able to zoom out, dive in the ontology and the graphs to understand what is inside for non-specialist people. And it's very important to be able to query the graphs, both ontology and knowledge graphs. So we need to have SPARQL storage of the ontologies and the graphs. And also, we might be able to reason and things. And so that's the reason why we developed open source tools to do this and trying to build a community around this now.
Great. Thank you very much. All right. Do we have anyone from a space industry ontology suite? Also a very cool title. But I think the time zone differences... Robert are here. Okay, he's here. All right. Good. Then I will... Yes. Hello, Robert. With the next one and then come back to you, Robert, because from our side, it looks like you should be available to do it. Yeah. Can you please take a look if it works with another application, like an audio recorder or something, and then we'll come back to you. Yeah. All right. Solution for soilless culture, nutrient.
Hello, can you hear?
Yes, now we can hear you. All right. Okay, I go back to you. All right.
Thank you. This project is about developing a suite or a set of ontologies for the space industry, broadly construed as the astronautical or spaceflight and astronomical or astronomy communities. It has origins around approximately 2011, and the relevance is similar to the manufacturing industry. There's a growing spaceflight sector, including astronomical activities and large volumes of space data. The project overlaps with artificial intelligence interests, as well as model-based systems engineering and various sorts of modeling. It aims in part to create a framework for knowledge representation and a set of conceptual, semantic, or ontological models and metadata elements. It's interdisciplinary. And my poster will present an overview of the project to date. And as a personal project, I'm also calling for formal support and formal partners and work collaborations. Thank you.
Thank you very much. Do we have anyone from the solution for soilless culture nutrient? I think from their colleagues from Brazil, and they are not here. No. Okay. Also not online.
I think the time.
Yes, exactly. So they're sleeping probably. So,
Yeah.
but sorry. Sleeping time in Brazil. Yes, exactly. So.
But maybe
Yeah.
they are in the evening.
Exactly. So if they're available in the evening, yes, we send our energy to their dreams now to call them to the session in the evening. All right. I think this is also from them, but you're here. All right. Yeah, other department. Right. Here.
Okay. So did you know there are thousands of sensors spread across offshore oil plants that deliver huge amounts of data each day to the operating companies? Navigating and accessing this data becomes a time-consuming task along the field life cycle. So I'm Nicolau Santos. Me, along with my research colleagues from Petrin Research Project from Federal University of Rio Grande do Sul in Brazil, produced this tool, Ontology Explorer, which is a visualization platform for time series data, which has an ontology as a backbone. This tool was used, had a domain ontology as a backbone. This domain ontology is on3PO, which is an ontology focused on offshore oil production plants, which is also a product of the Petrin project. And it was validated through a use case from a real-world scenario, and it used actual data from the industry for validating the tool. Right now, it's being enhanced to be better used by the professionals from Brazil. So one of the good things about this tool is that you can basically access the ontology taxonomy, its instances, parts, and properties, and then later find the data that you want, the time series that you want, and analyze the scenarios. If you are interested in talking about ontologies for oil and gas or ontologies for time series visualization, please come talk to me later on the poster session. Thank you.
Thank you very much. And the final, last but not least, maybe, if Gerhard is still not here. All right.
Thank you. In digitalization of science and research data, one of the main themes that we have is reproducibility. And there naturally, this is the only slide ahead. Okay, then naturally the question would be how to document reproducibility claims. So that which needs to be verified. And those claims have the form, if you do this and this process, if you repeat part of what I did, then your result should be somewhat in agreement with what I obtained. And this is something part of. You don't need to be identically doing the exact same thing. You don't need to wear the same shirt, the same, be in the same office, use the same login. That's not essential. And that's here what is called paradata. And what remains is the author data. And this is a formalism to document that, which is easy to implement.
All right. So if you're curious about what Martin just explained, find him at the poster session later. Okay. Anyone from EMO? It was a last-minute edition, but no one, I guess. Also not online. Okay. Then we are done for this with this part of the demonstrator session. So the first part of the demonstrator session in the morning, and the next session will be. Don't worry, we will go to coffee break. The next session will be about demonstration of industrial data documentation, and we will have 3 presentations. One from Patrizia, as she was also hinting during her poster presentation. She's online. And Katarina is there. Yes, she will be presenting from IKEA, her experiences with using semantic technologies in industrial data documentation. And we will have Evgeny either here or somewhere else, I think. Or?
I'll join face to face. Yes. What time my talk starts?
You will be the last one, so check from the agenda, and then you can. But you can be around, maybe here around 12, yeah, ish.
Sure.
Good, because the next session starts at 11:40, right? If I'm correct.
Yeah, after the coffee break.
Yes.
Break at 11:25, so you have a bit more time.
Yeah, I mean, we don't have to stay here, but okay. So 11:40 is the next session. So you can be maybe around here around 12. Yeah, Evgeny. So should be fine. Okay, good, great. Yeah, so there will be 3 presentations, about 20-minute presentation, 10-minute question answering. And of course, I mean, we are here for a reason. It's in person, so you can also maybe catch our speakers later after the presentations. Any questions regarding the poster or the session in the evening? Also from the online participants, of course. Yes. All right. Then something usually doesn't happen in such events. We are early. So yeah, please enjoy the coffee break, and then see you at 11:40.